L'Hopital's rule. And it's this idea that you could differentiate the top and differentiate the bottom, and you get to a limit. This is particularly usable when you have infinity over infinity or 0 over 0, some indeterminate forms. Now, L'Hopital's it's not useful in every limit, and so you want to be careful of what you use L'Hopital on. All right, so just keep that in mind. So with that being said, let's look at a couple of examples. This first one here, we have the limit as x approaches positive infinity of e to the x divided by x. Well, L'Hopital just says we take the derivative of the top, derivative of the bottom, and divide them, right? So in this case, this will be the limit as x approaches positive infinity of the derivative of e to the x is just e to the x over 1. Derivative of x is 1. And now you can see that we've reached a plausible destination where we could actually plug in this positive infinity for x. And that will just be 1 over e to the positive infinity. And you could imagine this number is getting really huge and huge, and 1 is staying constant. So this is just literally approaching positive infinity. Let's look at another one. The limit as x approaches positive infinity of x squared divided by e to the x. Well, again, L'Hopital says we could differentiate the top and the bottom and divide them. So again, this will just be equal to the limit as x approaches positive infinity of 2x, right, over the derivative of e to the x is just e to the x, right? And again, I still haven't found my limit because you can see this is still infinity over infinity, infinity over infinity. If you plug in infinity there, right? So we continue to say this is equal to the limit as x approaches positive infinity of 2 divided by e to the x. Right, and now you could see we've reached a plausible destination where we could just go ahead and plug in this positive infinity for e to the x. And you could imagine this number is getting really huge. This number is staying constant, so this is just approaching 0. All right, let's look at another one. This one's a little bit longer, but usually we would, use something like divide by the highest common, the highest factor of x in the denominator, and divide the numerator and denominator by that, and you would get to a plausible answer. However, L'Hopital is much more easy in this case, and we could just differentiate the top and the bottom. So this will just be equal to the limit as x approaches positive infinity of, well, it's just 5x to the fourth minus, well, 3 times 15, 3 times 5 rather, is 15x squared. Divided by 4 times 5 is 20x to the fourth plus 7. All right, and then this is still infinity over infinity, so you can imagine the limit as x approaches positive infinity will now be equal to, well, 5 times 4 is 20x cubed minus 2 times 15 is 30x. All right, divided by 4 times 20 is just 80x cubed, and the derivative of 7 is just 0. This still infinity over infinity, so we could continue. So the limit as x approaches infinity of 20x cubed, and I'm just rewriting this here, the second step here, over 80x cubed. Again, 0 over 0, so we just continue. So the limit as x approaches positive infinity, well, 3 times 20 is just 60, x squared minus 30, right? 3 times 80, well, 2 times 80 is 160. 3 times 80 is 240. So that will be 240 x squared. That will just be 240 x squared, right? And then again, the limit as x approaches positive infinity will be, well, 2 times 60 is just 120 x. Derivative of 30 is 0. All right, divided by, well, 2 times 240 will be 2 times that, 400. Right, so that will be around 480 x. Right, and then you could see you could just take the limit as x approaches positive infinity because we're still at 0 over 0. And that's just going to equal 120 over 480, which when you simplify will just be 1/4. All right, and it should be consistent with the horizontal asymptote of this function, right? Because you could see the horizontal asymptote, which is basically the limit, right? Should be 1/4, which is exactly what we got here. All right, let's look at the last one. The limit as x approaches 0 of sine of 5x over 4x. Well, again, this is 0 over 0, so the limit as x approaches 0, taking the derivative of the top, should just be 5 cosine of 5x, using the chain rule over 4. And now we've reached a plausible destination where we could just plug in 0 in for x. Well, 5 times 0 is just 0. Cosine of 0 is 1. So this is really 5 times 1 over 4, and that should be 5/4.